Hey, how's everyone doing? Hopefully you're great. This video I'm going to go through a notion that's called vertical angles. Vertical angles. And not only are we going to talk about what they are, what they look like, but we're also going to prove the vertical angle theorem. Okay? So we're going vertical angles and the vertical angle theorem. So here are some examples of places where we could have vertical angles. Now vertical angles are essentially in this X diagram, and they're angles that are across from one another. So this angle right here is vertical to this angle, right? We have 1, 2. Those two angles are vertical. And also we have another pair of vertical angles, the larger and its vertical angle, right? So this diagram has 4 angles, 1, 2, 3, 4, 2 pairs of vertical angles, 1 and 2. Same thing with the crossbars on the ceiling, right? 2 vertical angles here and another 2 vertical angles there. Okay? So vertical angles are essentially across from one another. Okay? So let's get that picture out of there. And let's move to a more geometric approach. Alright, so those are 2 intersecting lines, and we know that those 2 lines, if they do intersect, and they are distinct, different than they intersect at a correct point, right? Because 2 lines, if they do intersect at a point. So this situation creates 4 angles. 1, 2, 3, and 4, right? So we have 4 angles created by these 2 intersecting lines, and angles 2 and 4 are vertical. Put those in red, and angles 1 and 3 are vertical. They're across from one another. Put those in blue. Okay, so we have 2 pairs of vertical angles. We have 1 and 3, 2 and 4. So from this diagram, angles 2 and 3, excuse me, 1 and 3 are vertical angles. And also, whoops, there's another pair. Yep, you got it. Angles 2 and 4 are also vertical angles. Right? They're across from one another. That's what vertical angles, to me, represent. They're across from one another. Right? 2 is across from 4, 1 is across from 3. Okay? So there's what's called the vertical angle theorem. Right? And so I'm going to move from what vertical angles are, the definition, and well, not really a technical definition, but a general understanding of 2 and 4 being vertical angles and 1 and 3 being vertical angles. And now we're going to move to the vertical angle theorem. Okay, so this is our first theorem, and remember, theorem is something that's been proven to be true. And what the vertical angle theorem says is as follows. A pair of vertical angles shares the same measure. And we'll later call that congruent, the angles. They have the same measure. That means they're the same, they're congruent. And so really what we're trying to show is, go back to this diagram of 2 intersecting lines at a point. And we have 4 angles. 1, 2, 3, and 4. And just to stay consistent with what we did upstairs, 2 and 4 were in red, so I'll make these guys in red. And 1 and 3 were in blue. Right, so we have 2 pairs of vertical angles, and what the vertical angle theorem says is that the angles across from one another are equal measure. Right? So 1 and 3, if 1's 40 degrees, 3 is 40 degrees. If 2 is 140, 4 has to be 140. Right, so I'm going to prove that to you right now. So here's your first proof. Theorems become theorems because they have at least a proof that verifies that idea. So in order to prove that any pair of vertical angles have the same measure, I'm just going to show, let's just show 1 and 3 are the same, right? So I want to show that 1 and 3 are both the same. Okay, so here's how that goes, right? The first thing I want to notice is, what do you know about angle 1 and 2? Yeah, that's correct. They're supplements, right? Those are called a linear pair. So 1 and 2 have to add up to be, here's my proof, the first step. Note by linear pairs, right? We call that the linear pair postulate, right? Angle 1 and 2 are linear pairs, so they have to add up to be 180. So I'll write that the measure of angle 1 plus the measure of angle 2 equals how many degrees? That's right, 180. 180. It's a straight angle. Okay? And what also happens is diagram, not only 1 and 2 add up to be 180, but there are two other angles that also are linear pairs and also add up to be 180. Yep, that's right, 2 and 3, right? Angles 2 and 3 also add up to be 180, right? So I'll say similarly, angle 3 and 2 add up to be the measure of angle 2 plus measure of angle 3 also is 180 degrees. Right, by that same linear pair. 2 and 3 are linear pairs. They add up to be 180, therefore. 1 and 2 linear pairs. They add up to be 180. Now note that both of these equations are equal to the same value, 180 degrees, right? So 1 and 2 equals 180, right? Put them right under each other. And 3 plus 2 also equals 180, right? So if 1 and 2 is 180, 2 and 3 is 180, then if they're both equal to the same 180, then by the transitive property, 1 and 2 has to be the same as 2 and 3. Okay, so I'm going to say now, by the transitive property of equality, since both 1 plus 2 and 2 plus 3 are equal to the same thing, then they must be equal themselves. So I can say 1 plus 2, oops, sorry. Oh, doesn't want to do that. I'll write it out. 1 plus 2 has to equal not only 180, but since 2 plus 3 equals 180, 2 plus 3. 2 plus 3. All right? Because both 1 plus 2 and 2 plus 3 are equal to the same thing. They're both equal to 180. Remember, the transitive property says if any two things are equal to the same thing, then those two have to be equal. In this case, 1 and 2, 2 and 3. Okay? Now, what's going to happen here is what I'm going to end up doing is to show that angle 1 equals angle 3. Remember, that's what I'm trying to show, 1 equals 3. All I have to do is take 2 away from both sides. But what we have to do in proofs, we have to be kind of cheeky. So we have to say angle 1 is equal to itself, right? Before we take the same thing away from both sides, we have to say that angle 2 is the same as angle 2, right? And that's by the reflexive property, right? Anything is equal to itself, right? And so now what I can do is, since that angle 2 is the same as that angle 2, kind of silly, right? We already obviously know that, but sometimes math we state the obvious. And so now I'm going to subtract angle 2 from both sides. Boom. And get rid of that, measure angle 2. And what I'm left with is, by the subtraction property of equality, I'll just call it SPE, right? I subtract angle 2 from both sides. And what am I left with? If I take angle 2 away from the left side, I get angle 1. If I take angle 2 away from the right side, what am I left with? Angle 3. Okay, so what I just showed was that, hey, 1 equals 3. Right? 1 equals 3. Isn't that what I'm trying to show? Yeah. I'm trying to show that these two vertical angles, 1 and 3, are equal. And I just showed that. Okay? So that's a proof for what's called the vertical angle theorem. Any two pairs of vertical angles will be the same. So 1 and 3 will be equal. And then if I throw that 4 back in there, which I didn't need for this proof, but I guess I can throw it back in there. And just as 1 and 3 will be the same, angles 2 and 4, those vertical angles will also be the same, right? Okay, there's also a nice relation between angle 1 and 2, or 3 and 2, or 3 and 4, or 1 and 4. Any blue and red will be what? Not the same, not equal, but supplements. That's correct. So look, we can move to problems like this. So let's say that that angle There's two intersecting lines. And, oh, a little sluggish. Knock it off. Why is it doing that? Sorry about that. I'm going to undo that. What I want is, let's say this angle right here is, it looks like about 80 degrees. Let's keep it nice and easy. What we can do is we can use either the linear pair postulate or the vertical angle theorem to get all other angles, right? So let's start with the vertical angles. If this angle is 80, what does this angle right here have to be? That's right, 80, right? Why? By the vertical angle theorem. Right? Those two angles are vertical, therefore they have to be equal by the vertical angle theorem. Right? Any vertical angles are the same measure, they're equal. Okay, now what's also cool is that if this angle is 80, what's this one right here? No. Right, it's 100 degrees. Why? That's correct, because this angle, 80, is supplements with this angle right here. They're linear pairs. So this angle has to be 100 degrees as well. Not as well, period. Has to be 100 degrees. All right, and I'll put that in red, just so we're not staying consistent. Right? So look, we have vertical angles, these two 80-degree angles, and we also have linear pairs, which are supplements, and these two angles are also linear pairs supplements. Right? The last angle we need is this missing fourth angle, and we can use one of two ways to get that. We can use supplements, the supplement to 80, or we can use the vertical angle theorem, 100 by the vertical angle theorem. Right? So I'm going to just copy that, paste it, and by the vertical angle theorem, both these angles are 100. Right? They have to be the same as well. Okay? One problem for you to consider right now for homework, and here it is. Let's suppose this same diagram, if this angle is, let's say it's 40 degrees, and let's say this angle right here has the expression 2x plus 10. What I want you to do is solve for x. And then tell me what idea did you use. Okay? Solve for x. What idea did you use? All right? See you tomorrow. Have a good day.